Welcome back. This is Mr. Sutton bringing you our final lesson on parabolas. In this one, we'll expand our knowledge of transformations to perform dilations and reflections on our quadratic parent functions. We'll do our warm-up in a sec, but first let's get some terms out of the way. When we talk about a reflection, that means we're flipping the graph over an axis, usually the x-axis. The y-axis doesn't really change much when you reflect over that for a parabola. Dilations means we're stretching or shrinking the graph. So go to that GeoGebra site that we saw in the last lesson. There's the URL again, and see what happens when you change the A slider. We said we'd be getting to this one. So here's some things you can do with your A slider. See what happens when you multiply the whatever is squared by a negative, so make A negative. See what happens when your A becomes a number bigger than 1. Try to see what happens when your A becomes a number between 0 and 1. And the slider, unfortunately, only moves by ones, so you're going to have to kind of guess based on what happens when you go from bigger A values to smaller A values. But let's give this a shot. So here's my GeoGebra app. Here's my A slider. And I'm going to multiply this by a negative. So this becomes negative 1. And what just happened? Here was positive. Here's negative. So it looks like, based on that, we're flipping this over the x-axis. All right, let's try multiplying by a number that's bigger than 1. So let's make this positive again. And now we're multiplying by an A value bigger than 1. So the squared term is getting multiplied. And what is happening? And let's go back in the other direction as we get closer and closer to 1. And this is what would happen if we got between 0 and 1. What's happening is that A value decreases. So it's awfully tempting to say the parabola is getting skinnier when you multiply by bigger numbers and wider when you multiply by smaller ones. In fact, what is happening, and this is kind of difficult to see, you'll see it when we actually transform some graphs, but this is a vertical stretch that is happening. This is an outside change. So you're multiplying y values, and you're multiplying the y values by bigger and bigger numbers. So this is causing your graph to rise faster, which makes it look skinnier. By the same token, if you're multiplying by smaller numbers, you're shrinking it vertically. And if you're shrinking it vertically, that makes it look like it's getting wider. So in general, what's happening here, we're affecting the vertical in each of these situations. So I call this the multiplier rule. Whatever is happening to that squared parentheses or x squared, whatever that A value is, that is getting multiplied by all of your y values. Let's go and put this into practice now. For all the examples we're doing here, I'm going to use the table method, but just this once I'm also going to show you the parent function on the graph just so you can compare it and see what's happening to the different points. So here's the parent function, our classical parabola. Here's the parent table. And we're going to make a new table in a sec with the changes from this function. But what are those changes going to be? You've got a 1/2 outside the squared term being multiplied by it. So we understand that this means we're multiplying the y value by 1/2. And it's an outside change, so it's exactly what it looks like is happening here. So this gives us a vertical shrink. Let's go ahead and apply that in our table now. Now the x values aren't being changed at all. If we could somehow multiply stuff inside the squared parentheses by a number, then that would affect x values, but you almost never see that with parabolas. So x is staying the same. We're doing 1/2 times the y values. Here's all our original x values, -2, -1, 0, 1, and 2. Now the y values are going to change. So y value 4, that becomes 2. Half of 4 is 2. 1 becomes 1/2. 0 is going to stay the same. And again, 1 is becoming 1/2, and 4 is becoming 2. Let's graph these out now. So we've got -2, 2. We've got -1, 1/2, so kind of close in there. 0, 0 staying the same. We've got 1, 1/2, and 2, 2. And here's our new graph. So let's compare this to the old graph. Look at what happened to these points. We had a vertical shrink here, I mean, it becomes very clear why this parabola is getting wider if you look at these individual points. You'll see that all these points are being compressed closer to the x-axis. It is a vertical shrink. Let's take a look at another one. Pause the video and try this one on your own. All right, let's see what you came up with. So we've got our parent table, and the change here, we've got a negative outside, so that is a reflection over the x-axis, and we've also got multiplication by 2, so that's going to stretch our graph. So we're multiplying y when all the dust settles here by -2. That'll take care of both changes. So here's our new table. Again, x is going to stay exactly the same. Y is going to get multiplied by -2. So all our x values that we started with, we're going to keep them. For the y values, this is where we're going to change things. So this 4 becomes a -8, 1 becomes -2, 0 is still 0, and then we get those same points going the other direction, -2, -8. So we've got -2 comma -8, there's 4, 5, 6, 7, 8, there we go. -1, -2, 0, 0 stays where it is again, 1 comma -2, and 2 comma -8. On that last example, we were actually, as you might remember, doing more than one transformation at the same time, a dilation and a reflection. However, although those are technically different looking transformations, they both involve the same operation, multiplication. The only difference is that with the reflection, you're multiplying by a negative instead of just a bigger or smaller positive. But what happens when we have two different types of operations involved? What if we're doing a translation, which we know is addition, subtraction, and a dilation, which is multiplication? What if we're doing those two things to the same variable, so that we have to pick which one to do first? Which one goes first? So reasoning this out, again, translations involve addition and subtraction. Dilations and reflections involve multiplication. If you have to choose between doing addition or multiplication first, what are you going to go with? Well, PEMDAS tells us that multiplication happens first. So for that reason, dilations and reflections need to happen before you do any translations. Now, I guess we could just hope and pray that we never have to perform a translation and a dilation on the same coordinate, but those prayers not being answered in this lesson, because here we are. So here's our parent table, and looking at our function, we've got a dilation of 2, multiplying y values by 2, but we're also subtracting 5 from the y values. And then we've got x minus 3, subtracting 3 from x's, because again, inside changes are the opposite of what they look like. So we have a stretch, we have a downshift, and we have a left shift. Let's put all that on our table. So x, we're shifting left 3. That means we have to subtract 3 from the x values. For y, we have to multiply by 2 and then subtract 5. Again, PEMDAS requires multiplication to happen before addition subtraction. Let's go through now and fill in this table. So we have -2 minus 3, that's -5. -1 becomes -4. Then we get -3, and yes, these keep going up by 1. 1 minus 3 is -2. 2 minus -3, or 2 minus 3 is -1. Now let's do the 2y minus 5 column. So 2 times 4 is 8, minus 5 is 3. 2 times 1 is 2, minus 5 is -3. 0 becomes -5. 1 becomes -3. And 4 becomes positive 3. That's a lot to keep track of. I'm really glad we're doing this in a table. We'd be flipping all over the place if we tried to do this visually. So we've got -5, comma 3, -4, -3, -3, -5, -2, -3, -1, 3. Done. And now here we are, final boss battle. We've got everything going on in this parabola. So here's our parent function, and now just to sum up what we have going on, we've got a reflection with this negative out here. We've got a stretch with a 3, so we're multiplying the y values by -3. We've got a shift right of 2, so adding 2 to the x's, and an upshift of 6, adding 6 to the y values. Let's make our table. X values, we said we were adding 2 because we're shifting 2 to the right. Y values, we have to multiply by negative 3 and then add 6. It's really, you could just pretend this squared term is y in some formula. So this will be negative 3y plus 6. X values, we're going to get 0, 1, 2, 3, 4. If you can count to 4, you're good on this. Y value is a little tougher. So this will be negative 12 plus 6, so negative 6. And then we'll have negative 3 plus 6, which is 3. This will be 0 plus 6, so 6. And then our numbers repeat, 3 and negative 6. So here's 0, negative 6, 1, 3, 2, comma 6, 3, comma 3, and then finally 4, comma negative 6. Graph it out, and there we have it. That's all for now on transformations. Until next time, this is Mr. Sutton signing off.